hospital engineering systems, and it is basically under uh, hospital infrastructure as a module. So I want us to start looking at central utility plant overview, what it means, and that is all under hospital engineering systems. I want to say that a central utility plant are just houses of critical equipment for healthcare facilities, and these systems provide us power, water, fresh air, and others, and they handle this in the previous session. So utilities are just systems that provide additional quality patient care, and in addition to enhancing excellence in the facility, other functional duties like teaching and research. So while utilizing these resources in an efficient and cost-effective manner. So it's very important for us to have a central utility plant in all our facilities in order to provide efficient health services. So this central utility plant is basically looking at different kind of systems as we talked about them in the previous session. We looked about power, that is electric systems. We talked about water and we decided to categorize it under plumbing systems. We talked about fresh air and air conditioning. So basically we are looking at this as a system in relation to engineering within the hospital. So every hospital needs to have its utility services in order to ensure that operations are not actually brought down because of the inefficiencies that can arise from either utility systems failure. So it's very important that every hospital has to make sure that they have this central utility plant whereby they are able actually to provide services in relation to water, power, and others. So utilities are just the backbone of any quality healthcare system. Modern facilities are only thriving because of the availability state of the at utilities. So when you don't have power, you don't have water, and you don't have communication systems, you don't have engineering systems, then that one is going to affect the kind of services that you're going to provide to your clients. So it's necessary that every hospital has to ensure that they have these utilities to help support the provision of the healthcare services in their facilities. So I want to say that there are also very many importances of us maintaining these utilities. So the term utilities can also be referred to a set of services that are provided by either the government, entities, or organizations. Because we don't find power or water only in the hospitals, but we also find water power in people's homes and in different industries and other organizations besides the hospitals. And you realize that the water, the power is basically provided by the government, whereby the hospital has to pay for that consumption of water and power in their different facilities. So we find these utilities also in other different organizations besides the hospitals. So it is very important that the government provides these utilities in those various sectors. So ensuring the health of mechanical and electrical systems is crucial for health facilities and their managers. So when you don't have water, you don't have power, then you realize that you're not able to provide these services. So it is very, very key that electrical systems are provided so that the machines can run and so many activities will be supported in the facilities. The mechanical systems handbook, there is a mechanical systems handbook and electrical systems handbook that can help us actually to understand the different details on how we can guide the various healthcare facilities in relation to these utilities. So some utilities are often regulated by the government, and in hospitals they are centrally managed by the hospital. So the government provides, but they are centrally managed by the hospital, whereby the hospital has to make sure that they're able to control the use of their own facilities like the water, the power, they are controlled and regulated by the hospital management. So once the government is able to provide, it doesn't mean that he is also the one that is actually controlling in the hospitals. So these are centrally controlled and managed by the hospital management to see that these utilities are used adequately, they are managed adequately, and they are controlled adequately. So let's look at the mechanical system issues. Also, mechanical system issues are there in the utilities, and basically, I want to say that proper construction and maintenance of mechanical systems are very vital because if these systems are not constructed well and they are not maintained, then they cannot be able to function the way they are supposed to actually function. So proper construction and maintenance is ideal in a way that they can be able to actually continuously provide the services that they are entailed to. So these systems also include the following: heating, and we talked about HVAC, whereby it is heating, ventilation, and air conditioning, which actually need in our hospitals. So when you don't have this, then some of the services and some of the comfort of the patients will be affected, whereby the hospitals need to have higher standards of these mechanical systems in order to promote infection control, patient comfort, and energy efficiency. So when you look at mechanical systems, we are not talking about anything, but we are just looking at the different machines, the different equipments that are used in the hospital. How are they actually maintained? How are they constructed? And how are they placed or installed in the hospitals? So it is not just constructing or installing, but there are different standards that they're supposed to actually follow in the process of installing and constructing them. So the hospital has to look at that before they start installing or constructing these different mechanical systems. So when you look at promoting the infection control, basically we are looking at these mechanical systems in relation to either sterilization, disinfection, and that's where we apply the autoclaves because we have to make sure that all the instruments, the equipments that we are using are actually sterilized or disinfected. So the hospitals need to have these higher standards of these mechanical systems in order to promote infection control, patient comfort, and energy efficiency. So energy efficiency looks at providing power, and this is electricity where we need the lighting, and it has to be efficient so that it helps us actually to provide the services, and also it promotes the patient's comfort. So we need all these services in place, and they have to be done in a standard that is expected for the hospital to function. What are the key mechanical system issues? Basically, there are also some mechanical system issues that have to be looked at. We have to talk about the codes and regulations. When we talked about hospital designing and planning, we mentioned about following the codes and regulations of construction of different buildings or hospital spaces. So when you look at also the mechanical systems, when we are installing them in the hospital, we also have to look at the different codes and regulations on how they are supposed to be actually constructed and installed. So when this is not followed, it will affect the efficiency and effectiveness of the system, and so the quality of services. So if we are supposed to follow the codes on how we are supposed to install either our generators, our electrical kind of center points, and we don't put them well, then it is going to affect. So there are also codes and regulations in relation to mechanical system installations. So energy efficiency is more of using less energy to perform the same task or produce the same results. For example, when you use the energy saving appliances, one of these days people are focusing on using energy saver bulbs, whereby they don't actually take a lot of power, but they help to save electricity. So that is what we can relate to energy efficiency. You're able to use some equipments or appliances in the same way that you can use the other ones that can take a lot of power. So even generators are one of them, whereby we can install generators in our different facilities, and they are able to actually serve the same purpose as we can use electricity. Then solar panels, people use solars, and the solars can also do us good. And in we actually have energy efficiency, because to not actually um, eliminate or affect the service provision. So because of the high power consuming appliances, this will actually increase the costs to the hospital. And that's why we have to use the energy efficiency appliances, which helps us to reduce the consumption of power. And when you do that, it will also help us actually to reduce the costs of paying electricity and so forth in the hospitals. So the powerhouse equipment should be of good quality and properly installed. For example, the boilers, the autoclaves, because poor quality and installation can affect their functionability. So the powerhouse equipments, these are equipments that we use actually for providing or for preparing or for supporting us when we are providing these quality services. So they have to be of good quality. The time when they are constructing them or installing them, they have to follow what we mentioned in the beginning, the codes and regulations, so that we can be able to install them appropriately according to the expectations of the standards. So when we do that, then we shall be able to actually promote efficiency of the services that we provide, and also promote their functionability, and therefore our patients will get a standard kind of care. Then HVAC, we talked about heating, ventilation, and air conditioning, and some of the indoor air quality. We need actually to have this and put it into consideration that some of these equipments are very critical in any hospital, so that we can be able to sustain life. And some of these equipments actually is like having uh, we need to provide oxygen to our patients, so we need to have them. When we don't have them, then we are going to affect the service provision of our patients. The air conditionings, those ones, we need the air conditioning in our laboratories. We need air conditioning in our theaters, because we have different machines that need to have different kind of temperatures. When it is very hot, it can affect them. When it is very cold, it can affect them. So we have to regulate the temperatures. So we need air conditioning, we need good ventilation, we need heating in terms of chills or coldness. There are so many different equipments that are actually needed in order to provide these HVAC systems. So all that is necessary for different hospitals in order to sustain life. So if you talk about HVAC, then you're going to talk about the critical equipments that actually sustain the life of our patients. Without that, then you're going to affect the service provision, and also you're going to affect the recovery of your patients. And the most key item in this is basically the oxygen that we provide to our patients, that they should be able to sustain their breathing, their respiration, so that they can be able to actually live. Without oxygen, then somebody is not able to survive. We also talked about energy efficiency in the hospitals, and when we talked about energy efficiency, we basically looked at the power saving. And in this way, I mentioned about to saver bulbs, generators, and solars. So hospitals need to focus on energy efficiency by using the energy saver appliances like the energy saver bulbs and generators and solars, and other examples that you can be able to actually list or remember. So in this energy efficiency in hospitals, we need to benchmark and see there are different hospitals that are using different energy efficiency equipments or resources. And when they are using them, they are able to tell us their experiences, and we can be able to adapt. And that is what they call benchmarking. You see the hospital that is doing well in this, and you ask them how they are going about with it, and you can be able to adapt and copy with. So we use it basically to help us save the use of power in our facilities. So we need to see and visit those facilities to know and understand how they are sustaining energy efficiency in their hospitals so that we can also be able to adapt. And in that way, we are able actually to sustain the different health services that we are providing to our clients. The other point in this energy efficiency is the energy to care, and that is the ASHES benchmarking program. And this program basically helps to track and reduce energy consumption by providing tools to healthcare facilities to make continuous energy efficiency and sustainability improvement. And in this way, you're able to educate yourself and team on energy consumption trends and best practices. Here, what it is trying to tell us at this point is we can be able to benchmark in other facilities and see how they are able to use their power, how they are able to actually reduce the cost of power, and in that way shall also be able to cope up from them. But also, since we are able to understand that, then we are able to transmit the knowledge to other friends, other health workers within your hospital, and they can also be able to know how to use this energy efficiency kind of either equipment so that we can be able to sustain and improve the service delivery in our different facilities. So energy consumption is actually very important, and we need to make sure that there is energy efficiency in our hospitals to reduce the costs, and we can use the different kind of resources to make sure that we reduce the consumption of power. Because when there is a lot of consumption, then we are going to make also a lot of costs in our facilities because we need to run the machines, we need lighting, we need to carry out some other investigations, and we can't do without power. So efficiency is basically the way we use our power, the way we consume it, and the way we're able to control the use of that energy. You mentioned about HVAC, and the HVAC is basically heating, ventilation, and air conditioning. So this is basically looking at different kind of equipments and different kind of machines that are able to provide us different services or support us in the different healthcare services that we provide to our patients. So HVAC is essential for patient comfort and indoor air quality, whereby the medical gas systems, air, oxygen, nitrous oxide, nitrogen, and carbon dioxide basically the medical gas systems are considered very critical equipments in any hospital because of the role that they play in sustaining life. So when you don't have this, then you're going to actually deprive your patients from some of the services. So it is very important that we should have this kind of system whereby we are able to sustain and to promote the lives of our patients. And I mentioned most of these equipments are actually life sustaining. When you don't have this, then you're going to affect their life. So emergency power supply systems, which may be electricity or generator or even solar in any health facility, must have this on a bare minimum. So we really need this in case you don't have power, which is electricity, then you should be having either solar or you should be having a generator that is able actually to run these machines so that the services are not deprived from your patients. So we should actually try to ensure that we have this on standby. When you don't have electricity, the generator should be on standby. When the generator has no power, has no fuel, then you should be having either solar, which can help us for continuous service provision. So understanding the thermodynamics and psychrometric is very important. So psychrometrics is actually the use of the thermodynamics, and this is the way of analyzing the conditions and processes which involve moist air. So its understanding is very important in the heating, ventilation, air conditioning, and refrigeration, whereby the communities have to understand, or the hospital. Instead of the community, then we should say the hospital, because we are dealing with the hospital. So you need to understand how these machines, how these equipments are actually supposed to be run in the hospital. So this is what the statement is trying to tell us, that it involves the use of these thermodynamics just to analyze the conditions and processes that are involved in these machines, or in this service provision, in the use of heating, ventilation, and air conditioning. Even in the refrigerators, we need to understand, because refrigeration is one of the equipments that is in HVAC. So HVAC is very key in our service delivery, and is a system which controls very many machines in the hospitals. So some of this um, can be the autoclaves, which helps us in infection prevention, because we use them for sterilization. And when you sterilize our equipments, they become free from microorganisms, and we're able to control infections. So that is in relation to heating. Then for the case of ventilation, we need fresh air in our rooms, and we need good ventilation. When you talk about air conditioning, we have different air conditioners that we can apply in the different rooms. And for the case of the labs, we need them because they can help regulate the temperatures of our machines, since they are running every time that we are using them. They generate heat, and they need to be actually controlled. The heat does not need to be so high in these machines, because when there is too much heat, it can also break them down. So we need this in order to regulate the climate, or the temperatures in the different rooms when you're offering different services. Testing and balancing this HVAC is very key. These machines need to be tested. So this involves using test instruments, sensors, and monitors to verify proper temperatures, airflow, and other characteristics of the HVAC system. So testing establishes the quantitative aspects of the HVAC system, such as the volume of the airflow being produced, or best transfer rate. A properly balanced HVAC system can provide heating and cooling throughout the building. So, and this one can apply in the air conditioning, because when we need cool temperatures, the air conditioners can help us provide. But also, we need to test these machines, we need to test these equipments, and they have different sensors or monitors that are actually uh, are created, or they are made in a way that they are able to monitor how our air conditioners are working, how our autoclaves are working, and they can tell us that there is a problem in this machine. And in that way, we are able to rectify the problem. And also, they are able to tell us how much um, power is flowing through the machine. And the engineers are able to tell whether this is a normal flow or it is not. So we have to test our machines, and when we are testing them, we are able to actually tell whether the machine is operating normally or it is not operating normally. So this involves using different test instruments, and they can be able to sense and monitor the functioning of these machines during that time of service provision, or during the time when we need them. So therefore, testing, balancing, and adjusting these HVAC systems are actually critical tasks to improve the airflow that can help reduce hot or cold spots. So there are areas where we need cool climate, or temperatures that are not high, and that's why we need the air conditioning, that's why we need the ventilators. So when we use these instruments that help us to test about the temperatures that are running within these machines, then we are able also to actually understand that this is not right for this machine. But first of all, the engineers need to know the normal temperatures of the functioning of different machines in the hospital, so that they can be able to detect and understand that at around this time, when these temperatures are high, then we need to see how to cool these temperatures. So this HVAC system is actually critical in a way that it helps to understand the airflow of the different uh, machines, and it can help us actually provide um, help us in ensuring that we reduce the temperatures in those different areas, whether in the theaters, whether in laboratories, anywhere that we need a different kind of temperatures, we can be able to regulate when we test, and we can be able to balance them. So commissioning is actually also essential for optimal system performance, which helps verify and ensure the building systems are installed and operating according to the criteria in the original design. First of all, I want to say commissioning is very key. We talked about commissioning in our previous lessons. And when we talked about commissioning, we said this one is basically looking at after the construction or after the installation, you're going to commission, and that is now when you look at your equipment or your structure or your working space or hospital space is now actually adequate to provide the services. So even in these HVAC systems or mechanical systems, as we construct and install them, there is time for us to commission them. So when you're commissioning them, you're actually commissioning them, meaning that it's now ready to perform its activity. So it is very important for you to commission any machine or any kind of system that you have installed in the hospital. And in the time when you're commissioning, they are going to look at actually the regulations, the guidelines, or the codes on how that machine or that equipment was supposed to be installed, whether you have installed it in the right way. And by the time they are looking at that, they are able to identify either mistakes or you did it well, then they can allow you to continue actually to go ahead to utilize that machine. Because most of the electrical machines, when you don't install them well the way they are supposed to be installed, then they are going to cause problems in our facilities. Either there will be an outbreak of fire, or anything can just blast and cause accidents in the hospital. So even in these machines that we install in the hospitals, the different mechanical systems that we install in our hospitals, they're actually supposed to be commissioned. And in the time of commissioning, they are going to look at actually how you have installed. Did you look at the guidelines on how you're supposed to install that machine or that equipment? Did you have all the documents that guaranteed that this equipment is going to be installed in your facility, so that they can allow you to use it? And when you use it, you are actually knowing that you are using it, and everything is actually done in the right way, so that you don't cause accidents, you don't cause problems to your facility and also to your patients, including your health providers. So when you look at electrical system factors, there are different factors in relation to electrical systems. So electrical systems control every aspect of the hospital. So when you look at the services that we provide, the majority of the services that we provide are related to use of electricity. So even at night, we need electricity, whether during day we need electricity, and so many machines, so many equipments need to run with electricity. So electrical distribution systems like the adapters, these meters, the transformers, and then the step down and up kind of appliances are actually needed to help run the systems. So when you have electrical systems, we need to have um, these different appliances, so that they can help us actually control the running of this electrical system in the hospital. So we need the adapters which help us to distribute, we need the meters in different either working spaces or different buildings, whether wards or departments we need. Then we need transformers, and these transformers helps us actually in the controlling of the power flow in the hospital or in the different sections. So some people prefer to have a specific transformer for a specific hospital or specific area, whereby in case of anything in that place, they're able to actually control and they're able to respond, knowing where it has happened from. And in that way, they're able to control some of the disasters that happen due to electricity. So they must also provide reliable and safe power 24/7. 24/7 meaning every day and all times, meaning that alternatives for power should be on standby, like the generators and solars. So if you're not able to sustain power and you know that you're going to provide health services 24/7, then there is need for you to have an alternative for your power, so that when the electricity systems are actually broken down, you're able to switch on to the generator, you're able to switch on to the solar, and there's continuous service provision to your clients. So we need to understand also the codes and the safety of using these electrical systems, so that you can be able to avoid some of the blunders that can happen due to maybe breakage or misuse of these electrical equipment. So understanding the codes and the standards of installing these equipments is very key and so crucial for the safety of our patients, the safety of our machines, because we know that these machines are actually very expensive. And since they are very expensive, we also need to make sure that we handle them well. So we need to avoid blunders in types of electrical equipment. So when we are procuring them, we need to procure the right equipments, and we need to install them in right processes. We have to follow the procedures. We have to look at the standards so that we put them uh, in the right appropriate regulations and guidelines for the hospital. So in that way, we are not able, we shall not actually cause accidents in our facilities. So we need to look at these electrical factors as something which is very key, because we need power to help us provide services in the hospital 24/7, and we have patients 24/7. Every time people fall sick and every time people need our services, and most of the things that we need to provide the services are run by the electricity, or we need the power. And when electricity is not able to provide us actually what we need to run the machines, then we should be having solar, or we should be having generators on standby to help us actually provide the power that we need. If we don't have that, then it is going to affect our service delivery and it is going to make us lose our patients. So we should also be able to understand the codes and the standards of providing this or installing this power, so that it can be safe for our clients. So when you are procuring them and when you are installing them, we have to follow the codes and we have to follow the standards of safety, so that we avoid some of these fire outbreaks and danger to our patients. So the standards and the codes are very key. A basic understanding of the multitude of electrical standards and codes is very, very necessary. And when you look at this and you follow this, then you're going to ensure safety of your patients and the safety of your machines and safety of your health workers. Because when you don't follow the standards and the codes of installation of power, then you're going to make a lot of mistakes as you're installing your power and as you're installing your machines, and you end up actually even losing your machines, because some of them may get broken down because of maybe high voltage, since you didn't use and you didn't follow the codes and the standards of their installation, and you didn't actually follow the guidelines on how they're supposed to be installed, then your machines will either get a high voltage and they will break down. So following these standards and the codes during the time of installation of these different machines and the different plants of either power, water in our different sections of the hospital is very, very important. So some of the authorities that set guidelines for electrical systems have to be involved from the very start of the planning and designing for what kind of the electrical system you would like to install and what purpose it's going to play. When we're looking at the different authorities, we mean people who are responsible of power, people who are responsible of water, and people who are responsible of different kinds of systems or mechanical engineering in your hospital should be involved. Because if you don't involve them from the very beginning of planning and designing, then you're going to miss out on the installation, and it's going to affect the purpose of why you are installing it. So you need to involve them from the very time that you think about installing either power, putting on water. So those are all utilities that we need actually in our working environment in the hospital, so that we can be able to provide adequate services for our clients. So compliance with the state and local health departments at the Joint Commission and others is actually essential for a standard and quality operation or functioning. So we really need to comply with these different authorities, so that we can be able to provide a standard and quality operating equipments or machines in our different facilities or our different hospitals. So hospital engineering is very key to support the quality of services that we provide. So when we comply with the state and the local health departments, then we are able actually to follow these standards. And when you follow these standards, then we shall be able to provide that quality functioning of different machines, of different equipments, and those utilities will actually be able to play their role or purpose in supporting us in the provision of healthcare services in our hospitals. And then overcurrent protection, we need actually protection against electrical faults in the hospital setting, and it is very key and crucial. Most of our schools, as mentioned in the previous sessions, some schools have got actually fire outbreaks, and not only schools, but different organizations. So we really need to see that when we are installing these utilities, looking at power basically, we need to protect our hospitals, and we need to have a lot of protection against these electrical faults. And electrical faults can be maybe poor connection of power, and that can cause us problems. Having short circuits in different sections of our working places, which can actually cause either breaking of our machines, and also it can cause maybe if someone has touched it, can get shocked with power, which is something that is not good. So it is very vital for us to actually protect ourselves from these electrical faults. Then equipments like the circuit breakers, fuses, and ground fault protectors also play a very big role. So we need to have these equipment, so that they can help us in controlling the flow of power, in controlling and avoiding the short circuits. And by that way, it can help protect so many people, not only saying people, but I mean our clients, our health workers, from getting shocked with these short circuits. So equipment like short circuit breakers are very good for us to install in these different um, areas where we know that we are using electric equipment, so that it can help us actually avoid this. Then the fuses are also very good in controlling and regulating power. Then ground fault protectors are also very key for us to have for protection against different dangers of electric systems. So, we also don't forget the periodic evaluation to ensure protection devices to handle faults and being necessary. For example, we need the fire alarm systems and the smoke detectors. So we need this. We have to evaluate every time. um, we need to know whether our machines are functioning well. We need to check on the connections. We need to check on different sections of where we are connecting this, so that we can be able to, as we evaluate, we can be able to ensure that we have enough protection and our devices are actually not faulty. And by us doing that, it can help us prevent different problems that can occur due to electric issues. And we can also have fire alarm systems and smoke detectors, whereby these fire alarm systems can help inform us in case there is any danger that may occur or that is going to occur. There can be an alarm in a way that we can be able to know there is a problem that is going to occur, and we shall be able to address it before it happens. And the smoke detectors are also very key, whereby they can make an alarm and you realize there is something wrong somewhere and you're able to address it before any danger. So we need not to forget the periodic evaluation actually to ensure protection, and those devices can help us actually inform and we can be able to address before anything happens. So we need to install those fire alarm systems. We need to put also the smoke detectors within our hospital in different sections where we use this power, so that we can be able to overcome some of these dangers that occur due to fire outbreaks. The arch flash and selective coordination is also very key. The arch flash and selective coordination are actually related to overcurrent protection, and this helps to identify potential electrical hazards and violation of safety regulations within your facility. So the arch flashes occur during short circuits, causing electrical burns and shocks. So this is you realize when there is a short circuit, there can be some flashes of power, and you realize there is something happening. And I remember seeing this within some place where there was a transformer, and there was some kind of flashes, and we realized there was a problem, and people were able to call the electrical engineers, and they came actually and rectified the problem. So here you're able to actually assess and see where there is a problem, and you can be able to identify and you call for help. So arch flashes and selective coordination are related to overcurrent protection, what we had discussed in the previous slide, that we have to install that so that we can be able to detect the problem before it occurs. So even these flashes, they can happen in a way that they have not shocked someone, it has not either burnt anything, but it flashes and you realize there is a problem that needs to be addressed, and in most cases can be due to a short circuit. And when you see it, don't ignore. It needs to be actually handled immediately, and you can be able to address a problem before it occurs. So these arch flashes occur during either short circuits, and they can cause electrical burns and shocks. When someone goes around that area and touches, it can get actually short circuit and gets shocked, or it can even get burnt. So this is very important in a way that when you see, don't ignore, but take it seriously, and you're able to address it. And I want to give an example of when I was doing my internship, and that was in some hospital. We had ironing machine, which are using for actually ironing most of the linen, the bed sheets and so forth from the hospital. And this machine had a circuit which actually was not worked on, and they continued using it. So one time what happened was the person using or operating the machine was actually not also well trained. So when she went, she placed the clothes, the bed sheets, and when she switched on the machine, actually instead of taking the cloth in, it grabbed her hand, and when she called for help, the hand was actually ironed together with the cloth. So these machines need to be actually worked on using or following the codes and regulations. And when we do this, we can be able to actually make sure that we install these machines in the right way. And we also need to regularly evaluate them. We need to inspect them and see whether they are well connected so that we don't actually put our workers in danger. So this arch flash is basically looking at those flashes that fire tries to actually sparkle, and when it sparks, people sometimes ignore, and yet actually it is showing us there is a problem. So it tells us that it happens basically when there is a short circuit and can easily cause electrical burns and shocks to people who can go near it or who temper to touch. So understanding this arch flash risk and reducing incident energy is essential. So it is very important for you to understand that when this happens, it is not something easy, or it is not something that should be ignored, but it's something that can give like an indication to show us there is a problem. So it can help us to actually reduce some of the issues or dangers that would happen if we don't address it. So the arch flash analysis starts with gathering up to date equipment information, then performing a detailed analysis. So when you look at this happening, then you have to start actually getting the information about either the equipment, what could be the problem, how was it connected, how is it supposed to run, how much voltage of power does it need, and there you can be able to actually comprise all the information. And when you get the information, then you can be able to address, and you'll be able to know how much power was supposed to flow in that particular machine. In case maybe there was a high voltage, maybe it is the cause of that short what circuit. So you need to know about how much voltage that a machine was supposed to actually run, and there you can be able to understand whether it was having high voltage, and you can be able to address the issue by using different ways of controlling the flow of power, or the control the flow of voltage using different protective devices within the area where you're providing the service from, or where the machine is. So we need to understand this so that we can be able to actually see how to control and how to prevent different kind of dangers that can occur due to the operation of these different machines if they are not used well, or if they are not installed in appropriate way. So they are supposed to be installed using or following the codes and regulations on how they are supposed to be installed, and also the operation of these machines. They are different machines, but having their different guidelines on how they are supposed to be operated. So even operating these machines, they have to follow their different guidelines. And I want to again give an example of an autoclave, whereby when it is supposed to be run at a certain temperature for a certain time, when you delay to switch it off and continues operating, it refuses to open just because it has gone beyond the time it was supposed to run. So they have different guidelines on how they are supposed to be operated, and they have different guidelines on how they are supposed to be installed. So all that need to be followed and considered so that we can actually avoid breaking down our machines. And when they break down, they actually deprive us from providing the necessary services to our clients. So short circuits and protective device coordination study, as well as an equipment evaluation to determine that the current withstand rating is acceptable. So you need to know this, and I've already explained that you need to understand how your machines are supposed to be operated, what kind of protective device that you're supposed to have in place, and you're supposed to make sure that you always do an evaluation on your equipments. So when you do that evaluation, you're able to know the time of maintenance, you're able to know that this machine has broken down, and you're able to actually do either the repairs or provide the maintenance services for your machines. Most of the hospitals require reliable electricity with backup systems. So we need the backup systems so that we can be able to provide electricity 24/7 to provide services for our clients. So as having mentioned about to reliable electricity, we also talked about the generators. So the knowledge of the generators, fuel sources, and operational procedures is very crucial in managing the electrical systems in order to sustain our healthcare service delivery. So we really need to have this knowledge of how to operate the generators on the different fuel sources and also different operational procedures. So when we have this knowledge, it can help us to sustain power in our hospitals 24/7. So we need the backup systems, which are very key, and that is the generator. I talked about the solar, which can be a different fuel source to help us have this electricity reliable so as we can be able to provide services to our clients, because we cannot sustain services in our hospitals if we really don't have this reliable electricity that can help us run the different machines to provide the different healthcare services. There is some other thing about parallel operation of generators, and is a growing topic that people actually need to adapt if they can address most of the issues. And this is basically looking at two different generators and running at the same time, so that when one breaks down, then one can continue running. But they are all supposed to be of the same voltage operating and powering together, so that when one fails, the other continues supplying, so that we can maintain actually the and sustain the availability of electricity, and that one can address the issue of the backup systems. So there are hospitals that are actually able to have the standby generators, and not only one, they can have two. And when they have those two generators, they are all of the same voltage. And when they put them at that voltage, that means they have already assessed the different machines that they are using in their hospital. And those different machines have different power regulators to control how much voltage or how much power that those machines are actually able to run with. So it's very key for us to understand the different voltages of our generators that we have put as a backup for the power systems, so that we can be able to actually power up the different equipments or the different machines, so that we don't deprive the services, because we can have generators but they can be of low voltage, and in that way they are not able to power up the different equipments or the different machines, and in having the low voltage, they will not be able to actually perform the different services that we need them to perform. So the voltage of these different various generators that we need to be the backup systems should also be of a good voltage that can be able to run our different equipments, our different machines, to continue providing the services to our clients. So we do this basically to improve the reliability and enhance performance. So reliability is very important for power to be in the hospitals, and in that way they are able to enhance our performance of our health providers, because they cannot do other healthcare services, they cannot provide if actually they don't have this electricity or this power running to actually provide what they need to provide in case they are to use these machines. So we need essential electrical systems to help us with continuous service provision, so that we can be able to enhance and make sure there is real reliability of our services to our clients. Want to talk about patient safety. Patient safety is very key, and the first thing I want to talk about is using of the gases. When you talk about the HVAC, I mentioned the A means air, and we really know our patients depend, some of them, on oxygen. So we need a lot of oxygen. The air that we need is more of oxygen. We need others for either cooking and so forth. But when you talk about the oxygen, we basically look at the oxygen therapy that we give to our patients. So our patients actually need continuous support And the HVAC is basically looking at sustainability of life of our patients. And when you don't sustain their lives, then we are not able to actually make them recover, and there we are not actually providing adequate services. So patient safety is very key, whereby electricity safety is a priority in healthcare. So when we have electricity and it is a safe electricity, then we are actually prioritizing the healthcare, because we are able to provide the healthcare services because the electricity we are using is safe. It's not going to endanger our patients. It is safe in a way that is actually sustaining our machines to not break our machines, and also it is safe in a way that we are able to use it to support other healthcare services. So electrical safety is a priority in healthcare. And when we have electrical safety, then we are also prioritizing our patients' safety, because the healthcare services we are going to provide will be safe for our clients due to the availability of electrical systems. So grounding and protection from energized parts are key to avoid fire outbreaks and any other danger related to it. So when you look at electrical safety and you talk about grounding, when you look at the electrical engineering, there are some wires or there are some connections that are passed underground, and they have to be grounded in a safer manner. And that's why we talk about, in most of the emphasis, we look at the codes and then the guidelines on how to install this power. So grounding is one of the processes that is used for installation of power or electricity in different areas or in different organizations, in different facilities, and not forgetting the hospital. And then protection from energized parts are key to avoid fire outbreaks. So we really need to make sure that the grounding is done very well, so that this power is not actually going to endanger the lives of our patients, and is not going to endanger the lives of our workers and everyone around the hospital. So we have to look at this very critical, that anything that is going to be passed, all the wires that are going to be passed underground, should not cause either shock to our clients, should not cause shock to ourselves as health workers, or any other person who comes to the hospital. So there is a way they have to follow the codes and the regulations when they are doing this process, so that even if you pass over them, you are not going to be shocked. So they have to avoid fire outbreaks and any other danger that is related to this grounding of electricity or the wires that they are using for connecting power. So specific requirements apply to areas like operating theaters to ensure safety of both the machines and humans. So we have specific requirements or specific regulations or guidelines that are supposed to be followed during the time of installation of these electric equipments in these different operating rooms. So the operating rooms can be either theaters, it can be either in laboratories, anywhere where we need to operate these machines. So there are specific requirements that are needed to be followed. We have specific regulations, guidelines that are needed to be followed for proper installation in order to ensure the safety of both our machines and for humans, and the humans are either our patients or ourselves. So we need safety in a way that we follow the real guidelines when you are doing the installation of both the machines and the connection of our power or electricity in different areas of the hospital or in different working spaces of the hospital. So electricity is supposed to be used, but we have to actually ensure that as we are using it, we are also safe from it, because it can be more dangerous than actually giving us the advantage of it. When we don't follow the codes, when we don't follow the guidelines, and we don't follow actually the procedures on how we are supposed to install it, then we shall be endangering ourselves and everything around us. When you talk about lighting, lighting needs in we need lights in hospitals, and it varies across different spaces of the hospital healthcare provision, which basically refers to an intelligent networked system of devices that are related to lighting. And it controls the way it lights in a way that when we are supposed to have lighting in these different working spaces, we may have different kinds of lightings, and it depends on the type of services that we are supposed to offer. So the light control, we need the switches, we need different signals from other building systems, for example, the fire alarms or HVACs. So this can be different ways in which we can have different lighting systems. So lighting is very key. We need them in different spaces where we are working or we are providing our services in the healthcare provision. And when we need this lighting, we also need the switches. And those switches actually help us either to switch on, switch off when we need. Like during the day, we have the sun, which gives us the normal lighting, and during the night is when we need this lighting. So we need the switches, and also we need the signals, which can help us actually in different occurrences, like the fire alarms. We need them so that they can inform us during that time. Then also we need the HVAC. The HVAC is also very good, and we relate this in ventilation. So when we have very good ventilation, then we shall have good lighting, because our ventilators actually provide us good lighting. They provide us fresh air within the different working spaces in the hospital. So lighting is very key. It supports our service provision. Even during the night, you're able to provide healthcare services because you have the bulbs and you can be able to switch on and see what you need. You're able to see your patient, you're able to interact with your patient just like the day light. So it's very key to have lighting, and it is all about electricity. It's all about either the generators, it's all about either the solar, and we are able actually to run our activities during the night, just like the same way we can be able to run activities during at the daytime. So patient care areas require frequent cleaning and also specific lighting conditions for the safety of both our patients and healthcare providers. So lighting, we need to also look at different conditions in different rooms, in different working spaces, because in some spaces we may not need a very bright light depending on the condition of the patient. In other places we need bright light. So it varies on whatever service that we are going to offer. In other places we may need dim light, the time when we need our patients to rest, because when the light is very bright, then even our patients may not be able to rest, and yet at night they may be wanting to rest, and that is the time they can be able to actually refresh their minds and forget of what has been happening and all that. So patient care areas require frequent cleaning and specific lighting conditions. So the specific lighting conditions can move along with the conditions of our patients. So that looks at both the safety of the patient and the healthcare providers. So when we look at lighting, we don't just look at lighting of electricity, but even during day we have light, and that is all about the sunshine, which gives us even the brightness of the day. So when it is during day time, we don't use the bulbs, we don't use the electricity, we don't use the generators for lighting, we don't use the solars for lighting, because we have the natural light. But during the night is when we use these other supporting resources for lighting, and we're able to carry out our day-to-day activities. And the LED lighting is actually said to be efficient option that has been discussed by the latest handbooks, and they're expressing this. They say this one helps to reduce wastage of electricity, and these ones are just like bulbs, which are more of electric savers, and they're able to deliver efficient light generation with little wastage of electricity. So they don't waste electricity. They are more of energy savers, this LED lighting. So when you go and buy like maybe the bulbs and you want to fix them in different hospital workspaces, you can use the LED lighting bulbs because they actually help us to minimize the flow of electricity, but they are able to give us a very good lighting. So it helps to minimize the costs and wastage of electric power instead. So maintenance are testing, and we need to maintain our equipments. We need to maintain our different resources in relation to electricity or power. And also I talked about testing. We need to test the machines. We need to test how much power that they use. We need to keep actually monitoring them on how they are functioning, the voltage of power that is passing through them, how much air that they are releasing for the case of the ACs. And it's very good for us to know so that we can be able to maintain them. So customized maintenance and testing are crucial or critical for electrical systems. So every kind of electrical system that you're using or the equipment that you're using, you actually need to see that you maintain it and you keep testing or checking, or actually you need to be monitoring, you need to be evaluating whether it is actually functioning the way it is supposed to be functioning, whether it is installed the way it was supposed to be installed, and you're able to identify the problem before maybe it breaks. So maintenance and testing is very, very important in these electrical systems. So what is the importance of creating one-line diagrams and equipment labeling protocols? The one-line diagram is just like having one line of the flow of power. If you have a transformer, that transformer is going to supply one line or of power. And when there is a problem in that place, they are able to know that it could be either the problem from the other transformer, and they are able to actually trace and see how to address it. So even in our plant for power, for water, and all that in different utilities that we use, we are able to actually understand the flow of the different lines of power in our hospital. We are able to know, our engineers are actually able to know that when there's a problem either in medical department or medical ward, then it should be either from this side. So they need to know that one line flow. They have actually a diagram whereby they have drawn the flow of different utilities in our hospitals. So when you go to different hospitals, you're going to realize that either the director of the hospital or the engineer can give you the diagram or the map of the flow of different utilities in the hospital. They have the powerhouse, the original place where it's being disseminated to the different areas of the hospital. So it's very important to have this one line diagram or the equipment labeling protocols, whereby they know this equipment, when you reach here, you reach to the other one, then the other one, and the next one, so that they can be able to identify the different problems that can be occurring in the different kind of utilities. Looking at power, they're able to know what happens in those different lines, and they're able to identify and rectify that problem. So it is just because it provides a simplified representation of how incoming power is being distributed to equipment. And it's also used to document signal flows of different chains of our power. So when someone is actually trying to complain about maybe a problem in a different maybe ward or different workspace in relation to electricity, our engineers are able to trace, and they are able to actually identify where the problem is, and they are able to correct it because they know how the power is flowing. And this one simplifies for them to see how power is being distributed and how power flows in the different equipments or the different systems that are operating in the what? In the hospital. So having that one line diagram and flow of power is very important. It helps to direct and helps in timely addressing of the issues in relation to either power uh, problems. So tailoring maintenance to each healthcare facility is very essential. So when you look at this, you realize that it's very, very important when we have either problems with power, when you look at either the transformers and we have our different electric engineers, they are able to actually understand that there is a problem here and they'll be able to tailor their attention and their services to that specific either hospital or to that specific equipment, and they are able to repair it. So it's very key to tailor maintenance to each healthcare facility and see that they are able to handle the issues adequately. I want to give an example again of the hospital actually where I work. This hospital actually has sometimes issues with power, and they even decided to change the transformer and the line that supplies it, because in most cases at the time when you want to carry out either surgery, the theater is not having power and you have clients that you're supposed to attend to, and the transformer is companies have to tailor their services, the maintenance, and all that in relation to the healthcare facilities, because we need to sustain and we need to save life. So we need these machines to be running. Then hospital accreditation, ensuring quality health care. We really know that accreditation is very key, and I remember the previous topic that we handled was in relation to hospital accreditation. And hospital accreditation looks at basically the quality of care that we provide to our clients. So when you look at hospital accreditation also looks at the different mechanical systems that we install in our hospitals. So, in relation to the mechanical systems, let's look at about the relation to power and the equipments. So, the different services that we offer in our hospitals, the different services that we offer in our health facilities, they have to go through hospital accreditation process, whereby the authorities have to come and they have to see whether our equipments are really of good standard. Have they been installed well? And now, when we are talking about mechanical engineering and we are looking at electricity and water and the rest of the utilities, they have also to see at that time of hospital accreditation that we have followed actually the guidelines, we have followed the codes, and we have followed the real process, and we have all the documents that actually ensure that we have been allowed to install these different mechanical systems like power, water, and the rest in our hospital, and they are put in the right way. And when this is done in the right way, then they can accredit your hospital. And when the hospital is accredited, then we are being actually ensured that we have we are able to provide these quality healthcare services because everything has been done in a quality way. So hospital accreditation is very good because it can help in the maintenance of some of these equipments, like the installation of power and then the installation of those equipments when they are done in the right way. So hospital accreditation supports us in another way when we are installing these electric appliances or equipments, because we need to follow the right channels, we need to follow the codes and the regulations, and when they come for hospital accreditation, they have to look at all that. And when we have done it in the right way, we have followed the authorities, then we are sure that we are going to provide quality health care because everything is done in a good way. Then hospital disaster preparedness and response is also very key, because that's the only way we can also be able to maintain our equipments, we are able to maintain the flow of power because we are prepared. So what is hospital disaster preparedness and response? Disaster, we know these are just occurrences that can come when you're not ready for them. But you have to be prepared. Like a hospital, you have to be prepared to see that you're able to address either power outbreaks and you are able to prevent them, or you're able to actually handle them even when they have occurred, and that is when you are to respond when they have occurred. So it consists of a set of measures undertaken in advance by either government organizations like the hospital or individuals to better respond and cope with the immediate issues. So in the hospital, we have to be disaster prepared. And disaster prepared in relation to electricity, we talked about fire alarms, whereby the alarms actually make some sound, which can help us understand that there is a problem happening somewhere in relation to power, and we are able to actually respond and address. Then we also have the smoke. The smoke detectors, and those smoke detectors can help us. So we need to put all that in place so that we can be prepared. Then we also need to inform everyone where there is a control system, because when power breaks out, we need to run to the main control system so that we can be able to switch the power off, and the whole hospital will be actually protected and everyone in it. So this is very key. Hospital disaster preparedness looks at different ways on how we are able to handle this power in case there is any outbreak, or in case there is any threatening outbreak, and in case an outbreak occurs, how are you going to handle it? That's what this hospital disaster preparedness in relation to mechanical engineering is actually trying to explain to us. How we are able to understand that now this is going to happen. How are we going to mitigate it or prevent it? How are we going to handle in case it has already happened, or when it is even happening? We can be able to either look for fire brigade, we can be able to run to the main switch and put it off and all that. So we can be able to either save our machines and also save our patients and ourselves during that time of the outbreak or when it is threatening to happen. And then hospital maintenance and repair. When you look at maintenance, maintenance looks at something which a machine maybe has not yet broken down, and you want to just service it so that it can continues running the way it is supposed to, and maybe extend its period or its length, its life is all about maintenance. So hospital maintenance looks at very many things in relation to hospital. It can look at the structures, can look at the different equipments that we are using. But now in the relation of mechanical engineering, we are looking at like electricity. So we need to see how we are able to maintain. Before a machine breaks down, we are supposed to actually maintain it, because when it maintains when it is maintained, then we are not going to lose a lot of money in the cost of repairing, because repairing means that it has broken down and we are going to actually spend a lot of money either to repair, which may need some equipments, or it may end up actually making us buy another equipment which is very expensive. So routine activities for corrective or preventive, then repair is for restorative after breaking down or gets damaged and stops working. That's where now the problem is. When the machine stops working, then we are going to spend a lot of money, and we are going to also miss out the services that we are supposed to offer to our clients because the machine has broken down. So hospital maintenance is very key, that we need to maintain our machines so that we are able to run and continue providing the healthcare services. So this is actually the end of our session. I don't know if there are people inside there who have logged in and they have other questions that they need to ask, or they need to understand something. So